Hello class, good afternoon to you all. So I'm your tutor for the day. I am Ankesh Kumar. So we are here to learn mathematics in grade 9. In today's sessions, we will learn about number systems. Okay, so this is chapter first. Number system has its weightage of almost 10 marks. Fine. So our today's session is going to cover up to 6 to 7 marks. Okay, so let us start the session. So I welcome you all to my sessions, and I hope you all will pay your attention and you will enjoy the sessions. So let's take out your notebook and pen over here. So now, okay, so before we start, we will turn, we will we will know about the kinds of numbers that we have to learn over here. Okay, so there are two different types of number. One is a real number and the other one is imaginary number. Imaginary numbers. But in this grade we have to focus in real numbers only. We will also know a little bit about the real number, that what actually real numbers are. Okay, so let's start with the real numbers. Okay, so we know real numbers are the sets of, it is the sets of rational numbers, rational numbers and irrational numbers. Real numbers are the sets of rational and irrational numbers. All rational are real, all irrational are also real numbers. Okay, now coming to a little bit discussion on imaginary number. So let us discuss about imaginary number. Okay, so imaginary number is represented by small I, and this is a Greek word. This is a Greek word. Okay, and its name is iota, and a small I is equal to minus 1 root under. This is what we have to keep in our mind. Nothing to know more about this up to grade 10. Okay, so let us focus on our topic, that is rational and irrational numbers. So this is not the new thing that you are studying over here, that is rational number. You are already well versed and aware about the rational number from grade 6 onwards. Okay, so we have to discuss the meaning and the definitions of rational numbers first. Okay, so what is rational numbers? Okay, so rational numbers means, rational numbers means the numbers of the form P upon Q, where Q is not equal to 0. And what about P and Q? Yes, okay, so P and Q are integers, and integers is represented by capital Z. So I hope it is clear to you all. Fine, yes, okay. Now let us discuss about irrational number also, and after that we will discuss about the decimal expansions of the rational and irrational, and then we will come to discuss about the representations of the rational and irrational number on the number line. We have studied the representation of the rational number on the number line in grade 7 and 8 also, but in grade 9 we will learn a new topic, that is how to represent irrational number on the number line. Fine, okay. Now irrational number, simply we can say that the number which cannot be represented in p by q form. Okay, the number which can't be represented in p by q form. Okay, or you can simply say that all the non-perfect square numbers, the non-perfect cube numbers whose square roots and cube roots we have are what? The cube roots of non-perfect square number, and the non-perfect cube numbers are the irrational numbers also. For an example, we can write root 2, cube root of root 5, root 7, etc. So these are the irrational numbers. Now coming to the decimal expansions of the rational number over here. So can I change the slides? Okay. Has anyone doubt over here? Yes? Okay. Okay, beta. See, irrational numbers are the sets of numbers which cannot be represented in p by q form. And we can also say that the non-perfect square numbers and the non-perfect cube numbers whose square roots and cube roots is written is the irrational numbers here. Fine? Okay. Now let us move ahead to the next slides here. The decimal expansions of rational. So let me write here decimal expansions of the first one is rational and the second one is irrational. Let us see. Numbers. So we have the two different types of decimal expansions for the rational and one is for the irrational here. The first one is terminating decimal. Terminating decimals. So which kind of fractions has the terminating decimals? Okay. We will write it in notes. The fractions, the p by q form, where q is in form of 2 raised to power m into 5 raised to power n, or 2 raised to power m or 5 raised to power n. Means the denominator has its prime factor as 2 and 5 or 2 or 5 only. If there is any more number including with this, it will be non-terminating. It will not be terminating. For terminating, denominator must be in the form of 2 raised to power m into 5 raised to power n, or it can be either 2 raised to power m or 5 raised to power n. This is terminating decimals. For an example, I would like to draw your attention over here. That is 1 divided by 4. Now you can write 4 as 2 into 2. You can write 4 as 1 raised to power 2. 1 upon 2 raised to power 2. That is 0.25. This is terminating decimal. After the certain digits of the decimal, the remainder we have got over here is 0. So this is terminating. Terminating means this. Ending. Okay. Now the second one. So let us see it. Has anyone any doubt here? Okay, fine. So let us discuss about the second form of the decimal expansions, that is non-terminating but recurring, and this is also known as repeating decimals. Okay, non-terminating. It will not terminate, but after the decimal, the digit will get repeated continuously over the time. Now, for an example, let me write it. 20 divided by 6. If I divide 20 by 6, what do we get? It will result to 3.33.33. It means, what do you see? After the decimal, only one digit 3 is repeated over here. So this is non-terminating but repeating decimals here. So these two kinds of decimal expansions are rational. The first one is terminating and the second one is non-terminating but repeating. I hope it is clear to you all. Please say yes or no. Okay, that's great. So now we will discuss about the next one, that is irrational number. That is irrational number. Okay, in terms of decimal expansions, we will discuss about the irrational numbers. So what kind of decimals are irrational? Let's see. Irrational decimals are, I give you one trick on this, how to remember which kind of decimal expansions are irrational. Where you find two non, one is non-terminating and non-recurring. These are irrational number. You will see that the decimals are non-terminating, never ending, and it is not repeating. For an example, let me write 2.01010011 like this. This is non-terminating, non-repeating. I can write 1.232425 . This is irrational numbers here. Now I ask you one question over here. How many rational and irrational number lies between any two given numbers? Can anyone raise your hand? Okay, say yes, infinite. Great. So the question is that infinite number of rational and irrationals are found. Okay, now you tell me one more question. Can we get rational number in between any two irrational number? No. Why? No. Yes, we can get infinite number of rational in between the two given irrational number. That's great बेटा ये जरूरी नहीं है कि दो रेशनल के बीच में इरेशनल नहीं मिलेगा और इरेशनल के बीच में रेशनल नहीं मिलेगा. It is infinite. Now coming to the next topic that we are supposed to learn about here is that representations of the rational number on the number line. Representations of rational numbers on the number line. Okay. So how do we represent the rational numbers on the number line? Let us discuss it. So let us say if I have 7 by 9, if I want to represent 7 by 9, how will you represent it? Beta, all the rational numbers are represented in the same way. You have to follow the steps. That what are the steps required over here? The first step is to find the given rational number lies between which two integers. You have to identify the two numbers or the two integers in between which the given fractions or the rational number lies. So simply we can see it as this is proper fractions. This is what? This is proper fractions. This is proper fractions. And we know proper fractions is always less than 1. Proper fraction is always less than 1. So 7 by 9 is less than 1, but it is more than 0. The first step that we have completed. Any doubt in this step? Okay, fine. Now what you do, just draw a line. Just draw a line, make a demarcation point 0. This is 1 and this is 2. Okay, why we are only taking 1 and 2 like this? Because we have to represent this rational number which lies in between 0 and 1 over here. Clear? Okay. Now, taking denominator as 9, how will you write 1? 9 divide which number? We get 1. So 9 divide 9, we get 1. If you don't know how to find, just simply multiply this by this, you will get the numerator part. Similarly, this 0 can be written as dash upon 9. What will be in the numerator? 0 multiplied to 9, it will be 0 by 9. I hope it is clear to you all. That's great. Now, we have 9 in the denominator. So what we do, we will divide 0 and 1 into different sections. And what is that different sections? That different section is 9 minus 1. We have to mark 8 different points in between 0 and 1 so that it will be representing the given fractions here. Beta, if it would be 10, we would be marking 9 markers. If it would be 12, there would be 11. If it is 9, it will be 8 here. So 1, 2, 3, 4, 5, 6, 7, 8. Now we have 8 equal sections marked over here. Now 0 upon 9, 9 upon 9. After 0 upon 9, it will be 1 upon 9. It will be 2 upon 9. It will be 3 upon 9. It will be 4 upon 9. Like this way, this is 5 upon 9. This is 5 upon 9, this is 6 upon 9, this is 7 upon 9, this is 8 upon 9. So what we have to represent, we will mark it over here, that is 7 upon 9. This is the way that we can represent any rational number on the number line. I hope it is clear. Say yes or no. Yes, sir. Okay, fine. So we have represented rational number on the number line. Likewise, if we have to represent minus 2 upon 5 on the number line. So can you tell me the integers in between which minus 2 upon 5 lies? Okay. So if you don't know, just write 2 by 5. Okay. In order to get your confusion clear, just write 2 upon 5. It is more than 0 and less than 1. Okay. Now there is a trick. If we put minus sign over here, the sign of inequality will change. The sign of inequality will change here. So it will lies in between 0 and minus 1. It will lies in between 0 and minus 1. So what you do, just increase it. Right here as minus 1. Can I write it here? Okay, this is minus 1 here. Fine. Now it is minus 2 by 5. Na? So how you have to write this 0 and minus 1? Taking 5 as the denominator here. 0 divide 5. 0 divided by 5 will gives you 0. Now we have 5 in the denominator. Minus 5 divided by 5 will gives you minus 1 over here. Clear? Now how many sections you will mark over here? You will have to mark 4 sections. Why? Because the denominator is 5. So 1, 2, 3 and 4. Now you will write minus 1 by 5, minus 2 by 5, minus 3 by 5, like so on, minus 4 by 5. This is what we have to represent. I hope it is clear. Can I move to the next slide? Okay. Now the next one is to represent irrational numbers on the numbers line, and this is the last topic that we are going to discuss in today's sessions. After these sessions, we will discuss some more about the topics that we are going to left in today's session. Now we have another topic, that is representations of irrational numbers on number line. How will you represent? Again we have some steps that we have to follow. So let us see. I have to represent root 2 on the number line. How can I represent root 2 on the number line? Very simple. We all know about the right angle triangle. It follows the Pythagoras rule, Pythagorean triplets. So let's see, if I have a right angle triangle over here. Fine, this is a right angle triangle and the number is root 2. How will you get root 2? Just write A, B, C, right angle at B. If you take 1 as AB and 1 unit as BC, now what do you say about AC? AC will be equal to root under 1 square, and 1 square will gives you 1 plus 1 gives you root 2. It means that if we can draw this simple diagram, it will represent root 2 here. Clear? So now let us draw a line AB of 1 unit. Now what we do, we will make a right angle triangle. As you can see now, we have drawn right angle triangle over here. So at B, what I do, let me draw a right angle triangle. Fine. So by drawing a right angle triangle, we have taken the base and the perpendicular as 1 unit, so that it has given the hypotenuse value as root 2. So let me measure the arc AB as 1 unit and mark it as 1 unit more over here. Now join AC. Now this is root 2. AC is root 2. Again, what you do? Just produce it ahead. Make an arc AC and just draw like this and write it from here to here as this is root 2. Okay, let me write it as D point. This is root 2. If I ask you to make root 3, to represent root 3 on the number line, how will you represent? So how do we get root 3? First think upon this na. So root 3 is equals to root 2 square plus 1 square, root under will gives you root 3 na. 2 plus 1 will gives you root 3. So in order to draw root 3, you have to make root 2 first, and on root 2 what you do, just make right angle over here. Just make right angle over here. We have made the right angle over here. Now this is root 2 and take an arc of 1 unit and join it. Okay, so this is point E. Fine, I have marked it as point E. Now take an arc AE and draw it over here. Now this is root 3 unit. Like this way we can think upon the given irrational numbers and we can represent it. Clear? And one more example. If I have to represent root 5, how will you represent? So root 5 can be written as 4 plus 1. How can you write 4? It is root 2 square plus 1. So this is what. So how will you represent root 5? Let us see. The same thing. Draw 2 unit AB as 2 unit on the number line. On B, what you do? You will make a right angle triangle. How will you make the right angle triangle? You know it very well from grade 5 or 6 years. Fine. Now 2 unit and 1 unit. So what you do? You have to take half of this. So you will have to divide it. Now mark it. Join this as AC. Produce it ahead. Now AC is what? This is root 2 square and plus 1 square gives you 4 plus 1, which is root 5. Now take an arc up to this and mark it over here, and this is root 5. This is root 5. Again, if I ask you to draw root 6, how will you represent? Just draw 90 degree over here, make an 1 unit arc over here and join this. This will gives you root 6 and just mark it like this and write it as AE. This will be root 6. Like this way we can represent any of the irrational number on the number line. Any doubt? Okay, so that's all for today's sessions. Okay, now you all are subject to do practice questions from your textbook, and if you find any doubt, we will discuss and resolve your doubt in the coming sessions. So have a great day. We will meet in next sessions. Bye.